there are three types of computer instructions, three categories of them. One category is memory reference instructions, another is register reference, and the third is input output instructions. So as the name suggests, memory reference instructions are those instructions that operate on the contents of memory. So for example, I have to do addition. So the operand will be in memory. So I have to take the operand from memory and add it to the contents of accumulator register and then store the contents in accumulator. So this type of instruction is a memory reference instruction. Fine. So obviously this instruction will have an address which will refer to a memory where there is an operand. And there is another register reference instruction where this in this category those instructions fall which refer to a register. So the operand or something that on which we want to work is there in the register already, and we have to uh, act on that, maybe manipulate that, maybe shift that by shifting operation or some operation on the contents of a register. Third is input output instruction, where those instructions which deal with the input output thing. So taking things, taking a operand or a value from some input output device. So in a state of memory. So these are those categories of instructions. And the format will be accordingly. So the format of instruction decides which category it falls in. If I take an example, I say that my memory is, for example, of size 4096 into 12. So if the memory is 4096 into 12 into 16, for example, let us say the memory is 4096 into 16 size. So 16 means the instruction will be of 16 bits, fine, and address will be 12 because 4096 implies 12-bit address. And let us see for this example how will be the three categories distinguished. And if we say that this is the instruction 16-bit, the first 12 bits 0 to 11 is the address, fine, and the next here 3 bits 12, 13 and 14 is the operation code which will tell the processor that which operation it has to perform. It will tell the ALU whether it has to perform add or and or some other operation. And there this most significant bit which we call as I bit here, the 15th bit, in fact the 16th bit at 15th position, this will represent whether the instruction is a direct or a this address is a direct address or a indirect address. If things are like this, then this is a memory reference instruction, right? This is a memory reference instruction. And this opcode, since it is 3 bits, it will range from 000 to 110. So the opcode may be 000, 001, 010, and so on up to 110. In decimal, that means 0 to 6. Right? So only 7 entries, and the eighth entry, which is 111, that is a special case. What special case? If this opcode is 111 and 111, which is 7, then it is not a memory reference instruction. It falls in one of the two categories, whether it will be a register reference instruction or an input output instruction. Fine. So what will decide if this opcode is between it is 000 to 110, then it falls in this category. If this part 12, 13 and 14th bit is in this range, then this is memory reference instruction. And if it is outside this range there is only one value, that is 111. And if this is 111, then this is one of the two categories, either a register reference instruction or an input output instruction. Now again, how to recognize which instruction is this of this category or this category, will be decided this by this I bit. If this I bit is 0, then this is a register reference instruction, and if this I bit is 1, this is an input output instruction. Fine. So if this part is in this range, this is the first category. If it is 111, then we have to check this bit. If this is 0, this is a register reference instruction, and if this is 1, then it is input output instruction. So this way the processor realizes what type of instruction I have to execute. Okay. What operation is to be performed in a memory reference instruction, that will be here. For example, if this is 000, that will mean AND operation. Right? AND is to be done between the contents of accumulator and the operand that is at this address. It may be a direct or an indirect address. And if this is 001, that means add operation, and so on. And here these bits obviously do not represent operation, they just represent that which category they fall in. The operation will be here. These 12 bits will decide what is to be done on that particular register, and which input output operation is to be performed, that will be here. The operation will be here in these categories, but in this category the operation is here. So these are the three formats of these three instructions of a computer. And let us see this flow chart. This is a flow chart of an instruction cycle when we take all three categories of instructions into consideration. So what is an instruction cycle? We know that an instruction cycle is a sequence of steps that are followed by a computer to execute an instruction. Obviously, we know that an instruction resides in memory. So the first step in the instruction cycle is reading that instruction from memory, bringing that instruction from memory to processor. Then the second step of the instruction cycle is decoding that instruction. Fine. So decoding that instruction and realizing what instruction it is, what it wants us to do. And the third will be that if the address is an indirect address, if the address in the instruction is an indirect address, we need to read that effective address. So this third will be optional because it depends on the type of address. If the address is direct, we don't need to read the effective address. And if it is an indirect, then we need to read the effective address. And the last, when we know the operand and we also have decoded what to do, here we have realized it. For example, we have to do add. Here we have got the operand, and then we will do the operation, that is execute the instruction. These are the 4 steps of an instruction cycle. And if we draw a flowchart of the same, then we can see what will happen here. And first we say we are starting and we have put the counter to 0. The sequence counter is at 0. That is, this is a new instruction and a new instruction is being run. The sequence counter is at 0. Fine. And first of all, I have to fetch an instruction from memory. So that means there is an instruction at some place in memory. Where will that instruction reside? Obviously that address will be in PC. So PC means the program counter register. We know that the program counter register stores the address of next instruction. So the instruction will be at the address of instruction will be PC. So first we will bring the address into address register. Then we will read that thing from this address in memory, and then we will go into memory at this address. Fine, at this address in memory there will be the instruction, so we will read that. This is reading from memory, so we will read that. When we read an instruction, we know it that it is stored in IR, that is instruction register. Okay, so now we have done the reading. Simultaneously at the same time we will increment the PC, because now PC should contain the address of next instruction. Okay, so these two steps, this is fetch. So this fetching will occur in two time cycles. The Let us call the first time cycle as T0, then the next will be T1. So what is in this flowchart? These two time cycles, this is the fetch phase of the instruction cycle. Okay, now the fetching has been done. The second is decoding. So the second is decode the instruction. Decoding means understand the instruction, what is it? And we just saw here that this is the opcode, this part. So we have to decode this. What is this? This is 12 to 14. The bits 12 to 14, we have to decode them. So that means we have to take the 12 to 14 bits, 3 bits, 12, 13 and 14 of the IR, because the instruction is currently in IR, and we have to decode them. Decode means we put in them in a decoder. So when you put 3 bits in a decoder, decoder will have an output of 8. So it will be a 3 cross 8 decoder. So decoder will have 8 outputs, D0, D1, D2 up to D7. If this input is 000, then we know in the decoder D0 will be on, all others will be off. If this input is 001, then D1 will be on, others will be off, and we know decoder works like that. And at the same time, what we will do, we will the remaining portion, this is 12 to 14, fine. 0 to 11 we know is address, so we will put that into AR, because that is address. We just saw it here. 0 to 11 is address, so address obviously should go to the AR, that is address register. Now another thing is this I bit. So this I bit we will put in some flip flop which we call as I. Okay, so we got all bits. I is here, I into this, the 12 bits are into AR, and the 3 bits are into IR, the opcode bits. Now what we need to distinguish between, first of all we should know, decoding should tell us which category is it. Out of the 3 categories we just studied, which category is it? So how will that be known? That will be known by this. If this is 111, fine. If this is 111, what is that category? If this is 111, then it is one of these, and if it is not 111, then it is this, fine. So if this is 111, that means decoder D7 will be on, all others will be off. So the decoder D7 we will check. If D7 is on, that means it is one of these categories. Either it is a register reference instruction or an IO instruction. And if D7 is 0, that is it is off, then it is a memory reference instruction. So this is a simple way to recognize which category we are dealing with. D7 1 means that those 3 opcode bits are 111, right? Then if it is 0, it is a memory reference instruction. Good. Now if we go in this direction in memory reference instruction, In memory reference instruction, again, we have two types. Either it will be a direct address thing or an indirect address thing. We know how to recognize that. If this I bit is 0, it is a direct address memory reference instruction, and if it is 1, then it is an indirect address memory reference instruction. So that obviously will be here I. We just have to check the I now. If the I is 0, it is direct. If it is 1, it is indirect. Okay. Now, if it is indirect, what does that mean? That means we have to do this thing. Read the effective address. If it is direct, we don't need to do this third step. That is why we are showing here nothing at this time, clock cycle. If it is direct, we don't need to do this thing. And if it is indirect here, then we need to do this thing, read the effective address. How to read the effective address? We obviously will, the address which is given to us, AR, this is not the address of operand. We have to go to this address and then we will get the effective address. So we will go to memory at this location and there we will find the actual address of the operand. So this is the third step, this three, read, reading the effective address. Once this is done, then the fourth step is execute the instruction, that is here. So we will then execute the instruction, and once the execution is over, then we will again put the counter, sequence counter to 0, implying that this instruction has been completely executed. Now we can move to next instruction, and then it will be like this, making it a cycle, instruction cycle. And we know this was done in first time cycle, T0, then T1, then T2, then this will be in T3, fine. And this execution may take multiple time cycles, we don't know that, maybe T4, T5, some, and maybe only one, that depends on the instruction, fine. Now let us go in this direction. If D7 is 1, that implies it is one of the two. It is either register reference or IO reference. Again, how to distinguish between this and this? By this I bit we can distinguish. If this I bit is 0, it implies it is this category. If the I bit is 1, it implies this is this category. So again we will check the I bit here. So if it is 0, this is the register reference instruction. If this is 1, it is an IO instruction. Fine. If it, now we know here it is a register reference instruction. In a register reference instruction, obviously there will be no reading of effective address, nothing like this. We directly have to operate on the register, contents of a register. Then we will go to step 4, execute the instruction. And in this direction also we have to do an IO thing. That means operand will be directly taken from some IO device or given to an IO device. Then we will directly do this for execute the instruction. So here the execution here also it will be at T3 time, right? And this is the complete flow chart which is depicting an instruction cycle and is considering all three types of instructions. We can also put it like this here, that we can say here this is D70 means this direction, right? And the work is being done at T3, and this direction means I equal to 0. So if I have to go here, so this means D7 dash I dash T3, right? If I have to go there, this means D7 dash I dash and T3. T3 is the clock right now. If I have to go here, it will means D7 dash I T3. D7 dash I T3, we will reach here. So this type of instruction. What about here? If I need to go here, it will be D7 I dash T3. So it will be D7 I dash T3 to go here. And if I want to go here, it will be D7 I and T3. So D7 I and T3 means we will reach here.